All right, so we are up to, from the graph in my bulleted points that I failed to number, I know that probably doesn't make it better. From the graph, what is the position of the particle at t equals 3? So that doesn't mean calculate, it means look at the graph, all right? So here's t equals 4.1. I'm going to go back in time until I get to t equals 3. I'm going to go back in time until t equals 3. So, right, there's t equals 3.5. Just keep going down. T equals 3, all right? So my y is always going to be 1, but my x is 2, all right? So for that one, I'm going to say the position at t equals 3 is x of t equals 2, all right? Then it says, from the equation, what is s of 3? All right, so that would be s of 3 equals, now let's see, what was our equation? It was negative 3 cubed plus 7 times 3 squared minus 14 times 3 plus 8. All right, so that's not too hard to figure out. So we'll go to our calculator and we'll put in, so I'm a little too lazy to work that out. So there's nothing to obviously simplify it, but I can only say negative 27 plus 7 times 9, at least I can do that in my head, it's 63. And then 14 times 3, what is that, 52, or not 42? 42. So minus 42, and then plus 8, and it equals, hey, it's 2. Okay, so probably not surprising, but like what I want to emphasize is when I do s of 3, it tells me the position at time 3 is 2. Okay? So that's what that question is about. Let's see what it says next. It says, during what time interval is the particle moving to the right? Okay, so if I look at that graph of motion again, so during what time interval is it moving to the right? Well, let's see. Here it is, I'm going forward in time. I want to go backward in time. I go back till we're, why is it giving me x and y? Where's t now? I must not be in trace mode anymore. Yeah, trace. There we go. Okay, for some reason it got out of trace mode. If I don't see the t, I need to hit the trace button. All right, so I'm going to go back in time. Am I doing that? Yes. Okay, until we're off the screen. All right, so the question is, during what time interval is the particle moving to the right? So in this time interval, it's moving, right, this is backward in time, so forward in time, we're moving to the left. Then we're moving to the right in between those two times where it changes direction. So in fact, in between those two times that we already identified where it reverses direction. So the particle is, I'm going to start a new page for this. Particle is moving right on approximately, so what do we have? 1.6 to 3.1. T is an element of 1.6 to 3.1, approximately. Okay, so then the next question is, so then it asks, what is s prime of 2.5? That's a weird question for me to ask. I wonder why I asked that. So let's come back to what s of t is. So s of t is negative t cubed plus 7t squared minus 14t plus 8. We want to know s prime. It wants to know s prime of 2.5 for some reason. All right, so we're going to start by finding out what s prime of t is. So that's negative 3t squared plus 14t. See how good you are at getting derivatives already? All right, now I want s prime of 2.5, and you know this is really how we should write that. Now, I don't have to write out the substitution as long as I say that it's s prime of 2.5 and I see what s prime is, then I've given enough information to show where my result is coming from. So I have negative 3 times 2.5 squared. I'll be lazy and not see if that's like 6.25 or something. Probably is, but I'm gonna be lazy. And then plus 14 times 2.5, right? That would be 35, wouldn't it? I think it would. And then minus 14. And I get 2.25, all right? 2.25. All right, now, why did I ask this question? Because t equals 2.5 is in this interval. So what's interesting about s prime of 2.5? Well, I'll let you think about that and we'll look at the other two. All right, so then it says, during what intervals is the particle moving to the left? All right, so well, I won't repeat myself too much. It's pretty clear from, we've studied this graph a lot. The particle is moving left on t is an element of, so it's going to be every time that it's not moving to the right. So it's going to be negative infinity to 1.6 and 3.1 to infinity. All right, okay. So I should make these open intervals because at t equals 1.6, the object is not moving to the right or to the left. It's not moving at all at t equals 1.6. All right, so I should make all those open intervals. So that's when we're moving to the left. All right, so then it asks me for s prime of 0 and s prime of 4. All right, so s prime of 0 and s prime of 4. All right, so I'll just go to my s prime right there. So it's pretty easy to see what s prime of 0 is. It's negative 14. And what about s prime of 4? So, well, let's find out. Let's go negative 3 times 4 squared is 16, plus 14 times 4 is 56, and then minus 14. All right, so I'm just plugging in the 4 to s prime, and I get negative 6. Okay, now, these two values, t equals 0 is in this interval, and t equals 4 is in this interval. So, let me ask again, what is interesting about this number, which is s prime of 2.5, where 2.5 belongs to the interval where the object is moving to the right, and these two values, which come from t equals 0 and t equals 4 when the object is moving to the left? All right, what's interesting about them? All right, what is interesting about s prime of 2.5 is that it is positive, and what's interesting about s prime of 0 and s prime of 4 is that they are both negative. So what we are seeing an example of, not in any way a proof of, but it's an example of the fact that if I take a time when the object is moving to the right, then s prime is going to be positive. And if I take a time when the object is moving to the left, so one of these times, then the s prime is going to be negative. So it just means that s prime is positive when the object is moving to the right, s prime is negative when the object is moving to the left. We actually I think I talked about that on Monday, right? What is the relationship between s prime and the direction of the motion of the particle? S prime of t is greater than 0 if and only if particle is moving right. Or, by the way, if this is vertical motion, it could be up. And s prime of t is negative if and only if the particle is moving left, or if you're doing vertical motion, that would be down. All right, so that is sort of the conclusion that we're supposed to come up with from this lab. All right, and then it asks you to answer parts C and D of the question. What I would recommend actually at this point, instead of doing parts C and D of the question, just go to the homework, and we're doing this page 137, number 19 through 22 all, because these parts will be included in that. All right, so I would recommend you go ahead and start that part of the homework. However, there's more to the lecture today, so you maybe hold on to this, and the next thing we're going to talk about is the graphs of f prime and f double prime.